So we can use squares and square roots to solve these algebraic expressions for the unknown. So to solve, what we want to do is we want to use opposites. So I'm going to subtract 144 from both sides here. And I end up with a squared equals 25. Now if I want to solve for a, I need to undo the square. And I'm going to undo that square by square rooting both sides. Now, we're going to start worrying about this idea if I square root a squared, that means I'm trying to find out the number squared that equals 25. Well, that number could be positive 5, but that number could also be negative 5, because negative 5 times negative 5 is going to give us the same positive 25 here. So we're going to start worrying about this plus minus when we solve by square rooting. So here we have square root c is equal to 16 plus 9. So first thing I'm going to do is I'm going to add those together. And to undo a square root, to find c, I need to square both sides. So when I square root c, I get rid of the square root. Square and square root undo each other, so I end up with 25. Okay, so it's important that we don't square the inside. We're using the square to undo the square root. Same thing here. We're using the square to undo the square root. So notice that the black square root and the red are opposites, and they undo each other, and we're just left with the inside equaling the inside, which is what we should expect. For c, here I need to solve for a squared. Now, when I said that squares and square roots are different than times and divide, it's because times and divide can interact with plus and minus by distribution. Squares and square roots cannot interact with plus and minus. Okay? They do not behave the same as times and divide that way. They are different. This is why times and divide and squares and square roots are different. I cannot square root the square independently here because there's a minus involved. That's a big deal. Okay, the minus messes up anything to do with squares and square roots. So what I could do though is I can get rid of the square root, the whole square root, just like I did in the above, by squaring both sides of the equation. So I'm not going to do some calculations and apply square and square root here and here. I'm going to apply the square and square root to the whole thing. That will undo the square root. But I still left with the square root 29 squared minus the a squared. So what that red square root has undone is what the red square has undone is that green square root there. Okay, just like it would have done it here, the square and square root undo each other up there. But when I do that, I have to make sure that I do both sides of that equation. So I'm going to end up with 21 squared. Okay, and then I'm going to actually work out those numbers because now I can solve for a squared. Okay, so I'm going to do 29 squared is 841 minus a squared equals 21 squared is 441. Okay, so I'm going to do plus a squared to move the a squared to that side. I'm going to subtract 441 from both sides. Okay, I'm going to account for everything now. 0 pair, 0 pair. I end up with 400 on this side equals a squared on this side. So there's lots involved here, so I'm just going to start from the beginning here. I can't undo the green square root in the black square here and here because of that minus. It messes everything up. What I can do is I can get rid of the big green square root with the red square here by balancing the equation. So I have to square both sides. Okay, and then from here I'm just trying to get the a to one side, so I added a to both sides. Ended up with a squared on this side, and I want to get rid of that 441 on this side and put it onto that side by subtracting both sides. Now I can solve for a by square rooting. So I'm going to undo the square root, square by square rooting on both sides. So I end up with a is equal to, and we have to remember when I solve by square rooting, I get plus minus the square root of 400 works out to be 20. So when we're solving algebraically like this, we have to start worrying about this plus minus. When we're talking about using it for Pythagoras, which we'll do next, we don't really worry about the minus because we can't have negative lengths when we're talking about Pythagorean theorem.